So on yesterday, we dealt with the quadratic formula. Negative b plus or minus the square root, b squared minus 4ac all over 2a. So the big thing is the quadratic formula. We use it to find the x values, find the x-intercepts, etc. If we're only looking inside of the square root, then we're looking at the discriminant. So b squared minus 4ac, that's the discriminant. And that will tell you what kind of answers you should get. So that's where we started on yesterday. And then we got into actually solving problems using the quadratic formula. We got through examples 1, 2, and 3 before we ended yesterday. So just one particular note as it relates to your quiz. Again, this Friday you get your last quiz of the second quarter, last quiz of the semester. One part of your quiz is literally, here's a set of equations. You're going to solve one by quadratic formula, one by factoring, one by completing the square, one using square roots. And I think there's a couple of them in which you can pick any method that you want. But that makes up a pretty significant part to the quiz. But I'll give you more detail about that probably on Thursday. So, we're going to do one more example associated with quadratic formula, and then we'll look at the word problem setup that we have going on for this. So, example 4. So you have 2x plus 1 times x minus 5 equal to 5. So of course, if we're going to use quadratic formula, this equation's got to get equal to 0. So something has to happen to this, and something's got to happen to that 5. So what's the first thing we could possibly have to do? We got to do something to this problem before we even use the quadratic formula. So 2x plus 1, x minus 5, you're going to have to do FOIL. You're going to have to multiply that out. Do not just take 2x plus 1, set it equal to 5, and x minus 5, set it equal to 5. You're setting yourself up for disaster. So if you multiply that out, you end up with 2x squared minus 9x minus 5 equals 5. So again, that's from doing FOIL. And of course, you got to get the equation equal to 0. So 2x squared minus 9x minus 10 equals 0. So that's your first step. You have to get the equation in the standard form, and you have to get it equal to 0. That's the first order of business. Now we can go ahead and use quadratic formula. Negative b plus or minus square root b squared minus 4ac all over 2a. There's your a, there's your b, there's your c. So again, what I'm showing you is the bare minimum that you would need to show on a quiz, test, final, in terms of work. And keep in mind on your final exam you have 2 hours. The test is not going to take 2 hours. But that gives you more than enough time to show your work. Definitely give you plenty of time to show your work. So everything's set up, ready to go. Okay, the opposite of -9, so that's 9, plus or minus. -9 squared minus 4 times 2 times -10. Square root of 161. And 2 times 2 is 4. Any questions before we continue? If I messed up somewhere, please let me know. I'm definitely nowhere near perfect. All right. So the next step is to 161 is not a perfect square, so we're going to have to see if we can break this down, which I'll save you trouble. You can't break down 161. There's no perfect square other than the number 1 that will work for 161. So that square root is fine the way it is. Nine, 4, there's nothing you can divide out of that. So 9 plus or minus the square root of 161 over 4. That's your exact answer. That's your exact answer. So your approximate answers is actually working that out. Putting it in the calculator, working it out. So 9 plus the square root of 161 divided by 4 is going to give you one of your answers. And 9 minus the square root of 161 divided by 4 is going to give you the other answer. So just as I mentioned yesterday, if the directions tell you to give both, then you are required to give both. Don't just take it upon yourself. Make sure you follow what the directions ask you. So one of your answers is 5.42. And one of your answers is -0.92. So there's your 2 sets of answers. One of them is the exact answer, one of them is the approximate answer.
Mr. Lowe,
Yes?
can you explain how you got 161? I'm kind of confused.
Okay, tell me where you're confused.
When you were doing the math underneath the square root, you got 161 because I'm getting 121.
Alright, check that out. So we have -9 squared, which is 81, minus 4 times 2 times -10, which is 80. So that's 81 plus 80, 161.
Oh, I see what I did. Yeah, I got it. Thank you.
Mm-hmm. So, any other questions? Example. Alright, so that's quadratic formula in a nutshell if you're just, here's an equation, solve it. So the last 2 examples that we're going to work with puts quadratic formula into practice. This is also something that you probably have done or will do in your physics class some of you once you get to it, some of you while you're in it, and that's dealing with position. That's dealing with the position of something. So, first thing, give a brief explanation of this formula right there. So, this is your position formula. Describing the position of an object that is falling or is projected into the air. So, fireworks, anything that's shot up into the air, obviously it's not going to stay in the air forever. It's going to eventually come back down to the ground. So you have S equals negative 16 t squared plus v naught times t plus s naught. So, first S represents the height of the object. Most common feet unless told otherwise prompt. V naught represents the initial velocity. And S sub 0 represents the initial height. So that number is 0, that means you're starting on the ground. If it's an actual number, then you're starting whatever it is off the ground. And t represents time in seconds. So for the most part, you have to be given the height, the initial height and the initial velocity to set up the equation. So for example 1, during a chemistry experiment, the cork of a 0.5 foot tall beaker with a bubbly solution pops off with an initial velocity of 20 feet per second. So for part A, use the position equation to write a mathematical model for the height of the cork. So that you're essentially just setting up the problem. So this is nothing more than a setup. So the beaker is a half of a foot tall, and the initial velocity is 20 feet per second. So the 0.5 represents S sub 0, and 20 feet per second is your V sub 0. So you're essentially just taking the formula and filling in the values that you have. S equals negative 16 t squared plus 20 t plus 0.5. That's part A. Part A is more or less just you setting it up. Part B, find the height of the cork after 1 second. So, take the formula that you had. 1 second is your time. Plug in 1 for t. Squared plus 20 times 1 plus 0.5. So there you go. You let the calculator take care of the work. 1 squared times negative 16 plus 20 plus 0.5, which is 4, 4.5, and that's p. So the second part is just a plug and chug problem. Part C. So part C is the one that will take a little bit more time. And now you're going to use the quadratic formula. How long will it take the cork to hit the table? So cork pops off. You want to figure out how long it's going to take for it to finally hit the table. So that means your height, your height is now going to be 0. It's on the table. It's now laying on the flat surface. It's 0. Okay. So your 0 equals negative 16t squared plus 20t plus 0.5. So we're looking for time. Any questions before we go ahead through the problem? So let's do this. So, if we're using quadratic formula, the equation's already equal to 0, yay for us. That makes it easier for us to do our work. There's your A, there's your B, there's your C. So x equals negative 20 plus or minus square root 20 squared minus 4 times negative 16 times 0.5. All over 2 times negative 16. So we've got our setup. So the opposite of, let's put that in parentheses. The opposite of 20 is negative 20 plus or minus. Go inside the square root. So 20 to the second power is 400. Negative 4 times negative 16 times 0.5 gives you 32. Put those together, you get 432. If you didn't get that, please let me know. We'll go through it again. And then 2 times negative 16 is negative 32. Now, for word problems, you do not have to worry about giving the exact answer. We're going to use decimals. So for a word problem, don't worry about giving the exact answer. We're going to go right ahead and use a decimal answer. So with that, we have 20 plus the square root of 432 over negative 32. That gives you negative 1.27 seconds. And 20 minus the square root of 432 over negative 32. So that gives 0.02 seconds. So again, we're not worrying about the exact answer. We went right to the calculator to do our work. As far as time goes, you can't have negative time. So negative 1.27 seconds makes no sense. It can be disregarded. So your time, 0.02 seconds.
Aren't they supposed to be negative in front of the 20?
Let's see. Oops, you're right. Thank you so much. So that's going to change this up a little bit. So let me recalculate this. Negative 0.02, 4.02. And that one should have a negative in front. Negative 32, 1.27. So 1.27 seconds. Thank you very much for catching that mistake. 1.27 seconds. So for this particular problem, part A was simply setting up the formula. Part B was using the formula, find a particular height after however many seconds. Part 3, use the quadratic formula, find out how long it's going to take for it to hit the table or hit the ground wherever it's going to go. Any questions on any part of example 1 before you try example 2 yourself? Alright, so for example 2, fireworks are shot upward with an initial velocity of 125 feet per second from a platform 3 feet above the ground. So the first step in all this is to fill in the position equation. So in this case, you're literally filling in the initial velocity, 125, and the initial height, which is 3, which leads you to that equation. So again, part A, you're just setting up the equation. Part B, find the height of the fireworks after 5 seconds. So you're taking the equation that you wrote, plugging in 5 for T. So 16 times 5 squared plus 125 times 5 plus 3. And then you do the computation, order of operations, that takes you to 228 feet after 5 seconds. The last part is where the quadratic formula comes into play. How long will it take the firework to hit the ground? So if it hits the ground, that means your height is 0. So 0 equals negative 16 t squared plus 125 t plus 3. So now you don't know the time, that's what we're trying to figure out. So let's use the quadratic formula. If x equals negative 125 plus or minus the square root of 125 squared minus 4 times negative 16 times 3, all over 2 times negative 16. Continue the use of the calculator. So we have negative 125 plus or minus the square root of 15,817 over negative 32. So again, since we're working a word problem, we don't have to worry about the exact solutions. We're going to use the calculator to get our approximate ones. So negative 125 plus the square root of 15,817 over negative 32. To do that computation gives you negative 0.02 seconds, which of course is going to get disregarded because you can't have negative time. Your other answer, negative 125 minus the square root of 15,817 divided by negative 32. which gives you 7.84 seconds. So that's the answer that would be accepted per time. And then that would complete the project. So, position formula is simply using motion, modeling motion mathematically, and then doing some computation to solve out the problem. With that, that completes section 4.6. If you have questions, please feel free to let me know. Otherwise, have a good one, and I'll talk to you soon.